Hi, and welcome to 10.5 lesson on box and whisker plots and shapes of distribution. Today is going to be a little bit of review of what you learned probably in middle school, if not the latter part of elementary school, on box and whisker plots, interpreting box and whisker plots, but then also looking at new types of graphs called frequency distribution graphs, and showing how their shapes of distribution show variation in data, and that tells us what types of data is more important, and all that's going to make sense after we're done here. But the first part here, this should be a pretty basic review, as most of you have seen box and whisker plots before. Box and whisker plots are these boxes and then lines that go out. The boxes are a measure of several different medians, while the whiskers will go out to maximum min. The first line is the very middle line, the bluish line here. That is what is called your median. So all your data will be in numerical order, and then you just find the middle. Median's easy to remember because if you drive a car, you know that the median is the middle of the road. So it's also going to represent the middle of your data. So that is the median. You'll find the median by finding the middle number. The other two lines that make up your box are the left edge, which is called quartile 1, and the right edge of the box, which is called quartile 3. Those are also medians. So once you find the median of all of your data, you can find quartile 1 by simply finding the median of the left half of your data, and quartile 3 is the median of the right half of your data. Again, you'll see this here in a second. And then the whiskers part, the dots that go out, those will always go out to your minimum number and your maximum number. So let's look at an example. So here's an example that you're given. These are ages of the members of this backpacking expedition in the mountains. And so the first thing we need to do, if we're going to make a box and whisker, the first thing we need to do is we need to put them in order. So boom, in order. So you're going to put all the numbers in order, and obviously I'm going to go fairly quickly through here, so if you need time to write all the numbers down, just hit pause at any point in time. So I have written the numbers down. You'll see here that as I was writing the numbers in numerical order, I was crossing them out. That's always a good practice, is to cross out the numbers as you go. Therefore, you don't, or that way you don't miss any numbers and make any extra numbers, and just to make sure that your data is accurate. Once you have all the numbers in numerical order, we're going to then find the middle of your data, or the median. The median is the very middle. Now, the easiest thing to do is to really, and I think I can't do this at two different places, but basically you can cross them out as you go to find the middle coming from both sides. So I just use my fingers and cover up both the left and right, and then move into the left and right, and then left and right, and the left and right. And when you go and you keep going in, you'll find that the middle is in between two numbers. And that's always going to happen when you have an even number of numbers. Since there are 12 backpackers that are going on this expedition, the data set is even. 12 is there's an even number of people. So your median, when it's even, is always going to be in between two numbers. Now, in this case, it's the middle of 25 and 25, which is just 25. But if your data were like an odd set of numbers, like 13 or 15, then the median would be an actual number in your data set. But because it is even, it falls in between. And now to find quartile 1 and quartile 3, you're just going to find the median of the first half, which again has an even set of numbers. It's got 6 numbers here. So the median is going to fall in between two numbers. Now in this case, the numbers fall in between. They're not the same. So how we figure out this median is you take the two numbers that are on either side, you add them up and divide by 2. Now, this one was pretty easy. The number between 22 and 24 is going to be 23, but sometimes there's a bigger range here, and it might not be so easy to figure out. So the easiest thing to do would be to add these and divide by 2 to get this number. Then we move over to the right-hand side. On the right-hand side, again, 6 numbers, so it's going to fall in the middle between 28 and 30, so we can add those up, divide by 2, or just know that the middle of 28 and 30 is 29. Once you have your medians, you're now ready to create your box and whisker. The 3 lines that you've created are what is going to make up the box. Okay? Now, normally you do have to make a number line here so that you can easily see how the data is skewed, but I'm not really concerned with the number line as any application stuff, the box and whisker is going to be given to you anyways. So I don't care whether you draw a number line here. But the box is there, median, and then the 2 edges are your quartiles. Then you have your whiskers, which are going to go out in either direction to your minimum and maximum numbers. The second part of this is going to be interpreting the box and whisker when it's already been given to you. So here's an example of a box and whisker plot of the length of songs played by a rock band at a concert. And so a couple of things that they're gonna ask you to do is to find the range. So obviously we have songs, the biggest song we have, or the longest song I should say, is 300 seconds. The shortest song is 160 seconds. So when it asks you to find the range of your data, the range is simply just the biggest number, which is 300 in this case, and 160, which is the smallest number in this case, and then you just find the difference. So 300 minus 160 is 140. The range of my data here is 140 seconds. We're going to skip B for now. Distribution we'll talk about later, and we'll come back to it. So C, another thing here that you might not be familiar with is what is called interquartile range. Interquartile range is going to be where you figure out the range of your quartiles. So here's quartile 1 and quartile 3. So we're essentially just finding the range between quartile 1 and quartile 3. The range of 220 to 280 is going to be 60. And then D asks you, are the data more spread out below quartile 1 or above quartile 3? So is the data more spread out here above quartile 3 or here below quartile 1? And this is just a visual thing. Just look at it. It is clearly more spread out in below quartile 1. And the reason is because it has a larger range. Now, coming down here, we're going to talk about shape distribution of box and whiskers. And we're going to do this with frequency distribution graphs, but for here with box and whisker plots, this is how you tell whether your data is going to be skewed left, symmetrical, or skewed right. And what we want to pay attention to here is you have to understand the way data gets skewed. The data gets skewed by really, really low numbers or really, really high numbers. If everyone in the class had like an 80% on a test, but then one kid had a 20% on the test, that really, really low number is going to skew my data to the left. And vice versa, if everybody scored really, really low and there was one kid that scored really, really high, it's going to skew the data to the right. So how do you remember this? Just look at the tail. Whatever one has the longest tail is going to be skewed in that direction. So this longest tail here is going to be skewed left. Longest tail on the right is skewed right. And anything that looks like it's pretty in the middle is what we call symmetrical. So when we go up here to this data, is it skewed left or is it skewed right? And so we just look at which has the longer tail, or the longer whisker. The left side has the longer whisker, meaning this really, really low number is going to skew my data to the left. And that is what we call the distribution of data. All right. Now comparing box and whiskers here, your class versus your friend's class. If we're just talking about the shape distribution, the blue class is it's skewed left, skewed right, or symmetrical. When you look at the length of this left whisker, you can see that this is the long whisker, so it is going to be skewed left. Whereas your friend's class, this looks to be, you don't have to take out a ruler or anything like that, but it does look, though, it is pretty much in the middle, so this would be symmetrical. Which scores are more spread out? Again, that should be some common sense. Just look at them. Clearly, your friend's class has more spread out because it does have a larger range. So down here, the last part here is going to be what are called shape or histograms. These are called frequency distribution graphs, and we can also show skewed left, skewed right, or symmetrical for these as well. Frequency distribution graphs are going to be bar graphs that display the frequency of a number coming up, or frequency of, or the amount of within a specific range. So on the left over here, you see that these are raffle tickets sold, and then how many people sold this many raffle tickets. So this is a range, 1 to 8 tickets. 5 people sold with 1 to 8 tickets. 9 people sold 9 to 16 tickets. 16 kids sold somewhere between 17 and 24 tickets. And so what you do is you just simply make a bar graph based on this data. This is your X, so there's your X and there's your Y. And you just plot your X ranges down here, your Y ranges here, and you're just going to create a bar graph. Now here's what it looks like. You'll see all of my ranges down here, 1 to 8, 9 to 16, 7 to 24, 25 to 32. And then I just made a bar graph of the frequency of that particular range. Now, this, looking at the graphs here, we can tell that this looks like the middle one. Again, it looks like it's in the middle, so I would call this symmetrical. Now, it looks a little different with histograms when you're looking at whether it's skewed left or right. But just like with box and whisker, you look at the whisker to see if it's skewed left or right. With these histograms, you look at the tail, and that tail will show you whether it's skewing left or right. So the tail on the left means skewed left, the tail on the right means skewed right. But this one is pretty close to being in the middle, so I would call that symmetrical. The reason why we do these distribution graphs is to tell whether or not we should be using mean or median when trying to find our middle, or where the middle of our data is. You always use median. Median literally means middle. So you always are going to be using median to find the middle. The only reason you would use mean is if your data is symmetrical. So if you see your data is symmetrical, you would use mean. If your data is skewed at all left or right, you're going to use median. Most of the time, you'll end up using median. In this last example, we're going to be showing the police officer is targeting 30 motorists and collecting their speeds, and he recorded all the speeds in this table over here. And so what we need to make is we need to make a histogram, or a frequency distribution graph, using the intervals that they state here in the directions. They want 6 intervals beginning with 31 to 35 miles per hour, and then we're going to make 6 of those intervals. So what this will look like is starting with 31 to 35, there is all of my intervals. There are 6 of them because it said it wanted 6 intervals. And then basically all you're going to do is just count how many are in this range. How many are in this range? How many are in this range? This is the frequency. So how many speeds are from 31 to 35? If you count them all, there's only 1. And when you do 36 to 40, there's only 3 cars that were going in that speed, and so on. And all you do is fill in the distribution, the frequencies of each of those ranges. So you'll see between 51 and 55, 11 people were going between those speeds. Since there are 30 motorists, you should probably check and make sure that they all add up to be 30. So if you add 1, 3, 5, 6, 11, 4, it does add up to be 30, so our data is okay. And then you're going to graph it. Just like you did up here, you're going to take your frequency, you're going to make your x-axis, and oh, by the way, you're going to cross those out as you do them. And then you're going to make your graph. You'll notice the x-axis here with all the ranges here, and then the y values, make your bar. This one clearly looks like it does have a tail to it over here on the left. Since the tail is over here on the left, it's going to be skewed left. Now, because it's skewed, we know that we need to use median, because we always use median unless it's symmetrical, and then we use mean. So this one we would definitely use median. And interpret the results. If the speed limit is 45 miles per hour, so the speed limit is right here, basically. So it looks like most people are speeding. That's how you could interpret that. But that is it. If you have any questions, let me know. That's lesson 10.5.